It is not that I am so smart. It is just that I stay with problems longer. Albert Einstein. Dear students, welcome. Today in this lecture, we discuss few problems from Newton's laws of motion involving friction from my book Pathfinder of Physics, Olympiad and JEE Advance. Actually, in lecture number 24, we had discussed few examples of the same book on Newton's laws of motion without involving friction. At that time, we have developed a step-by-step strategy to tackle new variety of problems. Actually, that strategy is very much necessary when you tackle a new variety of problems. Actually, when we're practicing a chapter from usual textbooks, in those books we have routine types of problems. In routine types of problems, all the decisions you have to take, you know them earlier very well, only you have to combine your decisions. But in new variety of problems, you have to make your own decisions. In such situation, a strategy what we have developed earlier is very ardent. So first we revise that strategy and then we come straight forward on the problems involving friction, and we'll see how this strategy will help you in solving problems. The best strategy. This is the what we have discussed in last lecture, and there are few steps. First, make a physical model that appears first as a mental picture. Draw the picture if possible. Actually, when you start a problem, you read it. Situation described in that problem will create a mental picture in your mind, and if it is possible, draw that diagram and start thinking. Now think qualitatively, the process or mechanism involved and all the factors affecting the process or the mechanism. Actually, here what I mean by factors are usually physical quantities. How different physical quantities are affecting the mechanism and they are affecting each other. Try to think this idea qualitatively first. Your every decision must be based on the laws of physics. Avoid any common sense ideas. They are the biggest places of mistake. Actually, in physics, there is a great chance that an idea pops up in your mind spontaneously when you are starting a problem. And we use that idea, assuming it correct. But whenever an idea comes to your mind, try to check whether it is correct according to laws of physics or not. Actually, this is the major chance where we commit mistakes in problems, particularly in the subject physics. After a complete qualitative understanding, start writing relevant equations and then solve the problems. Actually, step-by-step procedure or strategy will help you much while you are tackling new variety of problems. Actually, at first sight, such a strategy may demand more time and you feel that you are spending much time on the problem, but please take care of things. This strategy will be helpful in a problem which has very new variety, and such problems will certainly demand some time, not in the execution of solution. They demand time in thinking what will be the solution. Now, rather than spending much time on discussing this strategy, let us come on example straightforward and see how such kind of logical thinking on step-by-step strategy will be helpful to solve you the problem. Example 01, that is question 30 of build up your understanding. What is the problem? A light block P on a horizontal tabletop placed equidistant from the pulleys supports a load with the help of a cord as shown in the figure. If the minimum and the maximum force applied by hand to keep the system in equilibrium are F min is equal to 40 Newton and F max is equal to 90 Newton, calculate mass of the load M. Acceleration due to gravity is G is equal to 10 meter per second square and this is a setup. Here this block P has no mass. Basically, its weight you have to neglect. Now, this load is hanging here. So, tension developed in the string, its downward component. Similarly, a pull is applied here. So, tension will be developed here on the string and its downward component. These two downward components of the tension in these two chords will produce necessary friction. Actually, that produce necessary normal reaction for the friction. And here the friction. Actually, because of friction, we need here two forces. Now, if minimum force is applied, you can think very well. This block will try to slide towards right and force of static friction will act here. Now, if the force is minimum, this static friction will achieve its limiting value. Similarly, if you increase the force and the case when maximum pull is applied, at that time, this block has tendency of sliding towards left and the force of static friction with its limiting value will act toward the left. Towards the right. Actually, if you think that idea, now the problem has been solved. Only you have to make equation. Now let us write the idea what we have thought till so far. A range of the pull suggests that force of static friction must act. It is toward the left when the minimum pull F min is applied and towards the right when the maximum pull F max is applied. As the block P has massless, the vertical downward components of the tensile forces of both the chords are creating the normal reaction necessary for the friction. And this is very important idea. Actually, this block is very light, but downward component of these two tension will create necessary normal reaction for the friction. The force of static friction counterbalances the net horizontal components of the tensile forces of both the chords. Actually, in all equilibrium, this force of static friction will balance the net resultant of these horizontal components of these two tensions. And it is obvious if force is very low to keep the system in equilibrium, then static friction will act in this direction. And if force is high to keep in system in equilibrium, the force of static friction will be towards right. Transmission of tensile forces in the chord, as we have earlier seen that whenever pulleys and strings are involved, the first step is to think how the tensile forces in the string are being transmitted from one place to other place. Let us see it. That is the setup. And here the weight mg, and these two angle will be theta because the block is equidistant from the pulley. So these two angles will be same. So here this mg will create tension T1, and that will be equal to mg because this block is in translational equilibrium. And here will again have tension T1, and this will be mg. Similarly, suppose a force F is applied here. This force F will create a tension T2 is equal to F, and this tension will appear here, T2 is equal to F. Now, we will avoid very common decisions. Suppose here T1 is equal to mg. We will not apply Newton's law separately and write Newton's law on block M and then T1 is equal to mg. Now, the decisions which you have to take very easily, just try to take it. And one more thing. In problems later to come, we will avoid showing the forces which are not necessary. So it will save time. Now we are in a position to think and solution. And certainly we have thought the solution qualitatively. So what the idea we have thought, we have to write equations according to those ideas. Translational equilibrium of the block when F min is applied. We know that when F min is applied, the force of friction is towards the left. And see, that is the free body diagram. So that is the block P, and here is the tension that will be equal to F min and at angle theta, and here is tension that will be equal to weight of the load mg, and that will also be at angle theta. Now here the vertical downward component will create normal reaction, so let the normal reaction be N1, and force of static friction will act in this direction. Now if this force is minimum, this static friction will acquire its limiting value. So this free body diagram we have drawn, and obviously if you take vertical as y and horizontal as x and resolve the component in that way, we'll find a very easy solution. So here x we are taking horizontal and y vertical. Now in this way, these two dashed lines will suggest the length of components. Now we have to show the components. So that will be mg sine theta and that will be mg cos theta. Similar here, this will be f min sine theta and that will be f min cos theta. Now what we can write? Summation fy equal to 0. We write here summation fy equal to 0 because this equation gives you normal reaction and will decide the friction. So from here n1 is equal to this component plus this component. It means f min cos theta plus mg cos theta. So we can write frictional force. So Fsm1 is equal to mu n1. Now that will be Fsm1 is equal to mu into this n1, f min cos theta plus mg cos theta. Now we are in a position to write equation for the x component. So summation fx is equal to 0. What it gives? That is this force plus this force will balance this force. So what we have? F min sine theta plus Fsm1 is equal to mg sine theta. Substituting Fsm1 and rearranging the terms, we get. Why we are rearranging terms? Basically, see here in the question, the coefficient of friction and the angle theta is not given. So we have to eliminate these two terms from equations what we obtain. So just we separate these terms here. So this will be f min minus mg sine theta is equal to minus mu f min plus mg cos theta. It's equation 1. And you can very easily get this equation. Now the similar analysis we'll do for the case when f max is applied. Translational equilibrium of the block when f max is applied. So again we draw this FBD. So here is the force F max and that angle will be again theta. Here is a load mg and this angle is again theta. Their vertically downward components are creating normal direction. So let us designate this normal direction by n2. And here F max is more. So this block has tendency to slide towards left. So force of static friction will be here towards right with its limiting value, Fsm2. Now FBD is complete. Again we take x horizontal and y vertical. So we can write Fy equal to 0. This will give you n2 and then we will be able to write friction. And then we'll write equation summation Fx is equal to 0. And for this we have to do components and these dashed lines again show the lengths of the components. So this will be mg sine theta and mg cos theta. Here f max sine theta and f max cos theta. Now summation fy equal to 0. What it gives? n2 is equal to f max cos theta plus mg cos theta. Now we can write frictional force. That is Fsm2 is equal to mu into n2 and let us substitute the value of n2. So Fsm2 is equal to mu into f max cos theta plus mg cos theta. Now we can write summation fx is equal to 0. What it provides? That is this force plus this force will counterbalance this component. So what we have here? F max sine theta is equal to mg sine theta plus Fsm2. Again we substitute this value of Fsm2 and rearrange the term. Cos theta one side and mu and sine theta on other side. So what we have? Substituting Fsm1 and rearranging the terms, we get F max minus mg sine theta is equal to mu F max plus mg cos theta. We call equation number 2. Now the two unknowns mu and theta can be eliminated if we divide LHS of these two equations and equate with division or quotient of right hand side of the two equations. So what we do? The same thing here. From equation 1 and 2, we get what we do. We will divide the LHS and RHS and equate them. So F min minus mg sine theta upon F max minus mg sine theta is equal to minus mu F min plus mg cos theta upon mu F max plus mg cos theta. You can see very easily the sin theta and sin theta will cancel, mu and mu will cancel, and cos theta and cos theta will cancel. So only we are remaining with the terms which are given. So what you got here, F min minus mg upon F max minus mg is equal to minus F min plus mg upon F max plus mg. Now just we do the cross multiplication. So what you get here, F min into F max minus mg square is equal to minus F min into F max and again minus mg square. So this here. Now we can transpose the term. So what we get here, 2 mg square is equal to F min F max, 2 and 2 will cancel. So what we get here, m is equal to square root F min into F max upon g. So that is the final answer. Now the thing is what, just we have to substitute the given values and find the numerical value answer. Substituting the given values, what we get, m is equal to F min into F max upon g, that will be 6 kg. So that was the solution. Now you can see again what we have thought qualitatively. Actually, all those thought have guided us to right solution. Actually, students are committing mistakes that before thinking the complete qualitative solution, they start writing equation, and in between they think what we to do next and what we do next. In this way, sometimes or frequently, they are not able to solve a problem which has very new variety. So just make it habit to use that strategy. Now let us come on the next problem. Example 2, that is question 33 from Build Up Your Understanding, and the problem is a block of mass m is equal to 5 kg is sliding eastward on a horizontal floor when its velocity is u is equal to 8 meter per second. In addition to the frictional force from the floor, a westward force F starts acting on it. Magnitude of this force varies with time according to equation F is equal to kT, where K is a constant that is equal to 5 Newton per second and T is time in seconds. Coefficient of friction between the block and the floor is mu is equal to 0.3. Draw a graph to show how the frictional force F on the block varies with time. Acceleration of free fall is g is equal to 10 meter per second square. Now, if you read the problems, a mental picture will be created in your mind, and you can see in your mind that a block is sliding on a floor towards east direction. Now, and of course there may be friction, but in the problem it is specified that there is friction. So if the block is sliding towards east, friction will be towards west. Now, in addition to friction, an additional force variable is applied when block velocity was 8 meter per second. Now this force is again what, in what direction? Towards west. So it will help friction. So it will speed up the retarding process. So the block will stop after some time. Now when the block stops, here you take a decision. When the block stops, if at that time, what is the value of this force F? This will create the friction, because when the block stops, static friction will start acting, and static friction is self-resisting. So what you can see, when this block stops, if at that time this force has a value greater than the limiting friction, then the block will instantaneously reverse direction and start sliding towards west. But if the moment when block stops, if this force is smaller than the limiting friction, it will take some time for the static friction to become equal to the applied force, and then the block will reverse direction and start sliding towards, that is in what direction? West. So this is the critical idea, and we have to write equation according to that idea. So let us write the quantitative solution. When the force F is applied, the block is sliding, so force of kinetic friction will continue to act pointing opposite to velocity of the block till the block stops. That is very important. So kinetic friction will keep on acting till the block is sliding. Now, two possible cases may occur depending on the magnitude of the force F at the moment sliding ceases. What the cases are? If the force F at the moment sliding ceases is equal to the or greater than the limiting friction, the block at once begin to slide in the direction of the force F, and force of kinetic friction continue to act with an instantaneously reverse direction. So that is very important idea. Now, second one, if the force F at the moment sliding ceases is smaller than the limiting friction, first, the force of static friction will increase, counterbalancing always the force F till its limiting value. Thereafter, the block will begin to slide in the direction of the force F, and the force of kinetic friction will act. So this is what the complete quantitative solution. Now, if you are very clear, so we can write equation. So what we do, first you find when the block will stop. Till that time, the force is constant, and that is kinetic friction. Now, when the block stop, you find the time, and we calculate this force F according to this equation. Now, we compare this value of force F with the limiting friction, and we take decision accordingly whether this case will be valid or this case will be valid. Now, let us see. Time taken by the block till it stops sliding. So that is very simple, and we have to apply Newton's laws of motion, find acceleration. NLM on the block, so that is a free diagram. Friction Fk is equal to mu mg, and the applied force F is equal to kT. So that is equal to what? Kinetic diagram Ma. So A will be what? Mu g plus K by M into T. Here A we have taken towards left, or you can say westward. Now this is A. Substituting the given values, we get A is equal to 3 plus T. Now we can verify the given value if we substitute, because mu is 0.3. So 0.3 into 10 is 3, and K by M, K is 5 and mass also 5. So it will become 1. So it will T. So A is equal to 3T. So this acceleration is retarding because it is opposite to velocity. Here the acceleration is a function of time and opposite to velocity. So what we can write? A is equal to minus dv by dt, and if you implement this, what we get here? Minus dv is equal to 3 dt plus t dt. Now we perform definite integral. Velocity changes from 8 to 0, that is limit. So here 8 to 0 dv my integral, and that is a 3 0 to t dt, and plus t dt 0 to t. And that is very easy to solve this problem. If we solve it, we'll get t square plus 60 minus 16 is equal to 0, and the only valid root is t is equal to 2 seconds. So when the force was applied, after that moment, 2 seconds after, the block will stop sliding, and we got this. So now what is thing? We had to calculate value of the force at t is equal to 2, and we compare it with the limiting friction. In this time interval 0 to 2 seconds, the force of kinetic friction, value of which is 15 Newton, continues to act, and this 15 Newton is again what? Limiting friction. And assuming positive direction towards the right, the frictional force in this interval is given by what? Fk is equal to minus mu mg. So that is Fk is equal to minus 50 Newton. What? For all 0 t in between 0 to 2 seconds. Now magnitude of the applied force F when sliding ceases, that at t is equal to, so the F was what? Kt, and K is 5. So this F is 5t, that is 10 Newton. And certainly this force is smaller than the limiting friction. So the block will remain standstill for some time till the static friction will increase together with this force, because this force is continuously increasing. When this force will become 15 Newton, at that time the block will start sliding in opposite direction as compared to earlier direction. When sliding ceases, the force of friction becomes static, thus will instantaneously change direction and acquires magnitude equal to that of the applied force. The static friction will increase till its limiting value as the force F will increase. Thereafter, sliding will start and a constant kinetic friction will come into action. So that is complete solution after t is equal to 2 seconds. Now just we have to write the equation according to this idea. So F is equal to Fsm, that is equal to F. That is what? When the block is basically again starts sliding. So 15 is equal to 5t. So t is equal to 3 seconds. So at t is equal to 3 seconds, the block will again start sliding in what direction? Opposite, westward. So in between 2 to 3 seconds, it is obvious. The force of friction is counterbalancing which force? The applied force. And thereafter, the force of friction will become constant. And see here. Thus, we can express the frictional force as first interval 0 to 2 seconds. So minus 15 Newton and 0 to why minus 15? Because we are assuming the velocity towards east. So friction is towards west. So eastward we have taken positive. So this is west. Now what will be in 2 to 3 seconds? Force is 5t and this why 5t? Because force is towards west. So static friction will counterbalance it. So the force of static friction will be towards east. So that is positive. And after 3 seconds, the block starts sliding. So force of friction will again become kinetic and that will be in the east direction. So taken positive. So 15 Newton when t is greater than equal to 3 seconds. Now we can draw the graph representing this function. This function is represented in the adjacent graph. So how? Just we take this graph here, the ordinate, that is numerical value of frictional force, and here is numerical value of time. So 1, 2, 3, 5 seconds and 15 and minus 15, because we know the frictional force will be in between minus 50 to 15 seconds. And all the events which are very important, that taking place at t is equal to 2 seconds and 3. So we are drawing taking time up to 5 seconds. So here, that is this dashed line, you can see here what 15 by 3, it means the slope is 5. So this dashed line is the applied force. And friction force till 2 seconds is minus 15. And thereafter it will instantaneously reverse direction and become static. And from 2 seconds to 3 seconds, it will counterbalance the applied force. And then it will become again constant. So that is what, how the friction force varies in this situation. Now the problem was, if you see at present, after making solution, you will find the solution is not very difficult. Only thing is what? This idea was the crux. What idea? When the block stops sliding, at that time you have to see whether the applied force is greater than or smaller than the limiting friction. And here is the point where sometimes we may commit mistakes. And when students are writing equation first, they try to extract such ideas from equation. Basically, such idea will never come from equation. Actually, equations are written according to these ideas. So these are the physical solutions or a qualitative solution. So you have to make the qualitative solution and write equation according to that. Now let us see the next problem. Example 3, that is question 34 from Built Up Your Understanding. A boy lifts a stack of several identical books, pressing hard with his hands. Coefficient of static friction between hand and a book is mu bh is equal to 0.4. Between the books is mu bb is equal to 0.25. And mass of the book is m is equal to 400 grams. So all the books are identical, as this is situation. And you might have done these things so many times. But what is a common experience? sometimes the stack of the books starts falling, and either we increase the hand push or just orient the stack vertically. But here you have to analyze this problem. The conditions when the stacks of the books starts falling, slipping down. Now the boys start decreasing the pressure gradually. When the horizontal component of the force applied by the boy becomes F is equal to 120 Newton, the books are about to fall. How many books are in the stack? Acceleration of free fall is Z is equal to 10 meter per second square. Actually, at that time, a number of books are not shown because this dash line means there are books to be continued. Now this scheme is just only used not to show a finite number of books. Now just see, this student was able to hold that stack. Now what he is doing? He starts decreasing the pressure by his hands. So when he starts decreasing pressure by hand, what will happen? The horizontal component of the force will decrease and it will decrease the friction. So at some moment, sliding will start and the stack of the book will fall down. If this force horizontal component becomes 120 Newton when this equilibrium is disturbed, then to find how many numbers of the books are here in the stack. Now let us see the qualitative solution here. First we write it. The horizontal component of the total contact force applied by the boy on either of the end books is equal to the force of normal reaction responsible to create necessary friction between the hands and the end books as well as between all the pairs of books in contact. Actually, you can see every book is in equilibrium and the stack is in equilibrium. So horizontal component of forces on everything from both the sides are equal. So that horizontal component of the force which is equal to normal reaction will be F. So F will be normal reaction. And all the books are in identical conditions. It means why they are identical conditions? Because normal reaction on all the books are same. So this if you exclude this book and this end book, all the inner books means if we assume there are n books, so from here to here n minus 2 books all are in identical condition. Only the book which is in contact with the hand is in some different conditions. Values of the limiting friction will play the key role to predict how the equilibrium will be destroyed or disturbed on decreasing the force F. Thus, we first find them. So, limiting friction between end books and hand, we denote it by FBHM. B means for book, H for hand, M means maximum, means limiting. That will be equal to mu BH into F. Similarly, we can write limiting friction between two books in contact. That will be, say, FBBM is equal to mu BB into F. Limiting friction between all the books are equal but smaller than that with hand. Thus, all the books except the two end books that are in contact with the hands are in identical conditions. What we have seen earlier, because from this second book to this last but one book, this from here to here, they are in identical condition, and these two end books are again in some other condition, but they are in identical. So what we can think? Thus, denoting total number of books by n, we have to analyze the situation by considering all the books in two stacks, that are the stack of all the n books and a stack of n minus 2 inner books as shown in the figure. So here that is a complete stack. So we take this is all stack of n books, Now this is what? Stack of n minus 2 books. Actually, this second stack of n minus 2 books, all the books are in identical condition, so there is no preference that which book will slip. What will? This entire stack will slip simultaneously when the equilibrium is disturbed. Either this n book will slip. So where is the slipping tendency? Either slipping will occur in between hand and this n book, or slipping will occur between this n books and this n-2 stack. On decreasing the force F, the equilibrium will be destroyed in either of the following two ways. What? First, sliding will initiate between the whole stack of the n books and the hands. And second, sliding will initiate between the stack of inner n-2 books and the two n books. It means that is only two situations may happen. Either the entire stack will slip from the hand, or these two books will remain in contact with the hand and this inner stack of n-2 book will slide. So how this will happen? Suppose this entire stack is sliding, so this way. Now how the second possibility will happen? If this inner n-2 book stack is sliding, so this sliding is like that. So we have shown not complete sliding, so that is what you can visualize it better. So let us see again, see this way. So if this slides in this way. Now if second possibility, that happens in this way. So what you can conclude, which of the above two possibilities are valid will be decided by considering the equilibrium conditions of these two situations. So let us analyze the equilibrium condition of both these two situations. First, sliding initiates between the whole stack of n books and the hands. So we'll draw the free body diagram. So these are the two force F. This F is what? This is not the total force applied by hand. Actually, if you see, the total force applied by hand is the resultant of this force and friction. That's why it is written in the problem. The student start decreasing pressure of this hand. The student, okay, now, so let's see here, this force, and of course we have seen that this force will be equal to normal direction everywhere. Now here, that is nmg, the total weight of the books. So that is these two frictions, they will be identical, FBHM and FBHM, because when sliding initiates, these two friction will acquire their limiting values. So here we can obviously y vertical, x horizontal, so we can write equation summation Fy equal to 0. What it gives? 2 FBHM is equal to nmg. So we can write n. From expression of the limiting friction, we get, what was the expression of limiting friction? That was mu bh into capital F. So what we have? N is equal to 2 mu bh into capital F upon mg. So this we substitute by what? Mu bh into capital F. So in this way, you can calculate the total number of books in stack. Now let us calculate this value. On substituting the given values, what we get? N is equal to 2, this is 0.4, and F is 120, M is 400 gram, and G is 10. So that comes to be 24 books. So in this way, the student can hold 24 books, but if it is possible. Now if you see the second possibility, if in the second possibility, the number comes smaller than 24, so we have to take that one. So what is the second possibility? Sliding will initiate between the stack of inner n-2 books and the whole and the two n books. So that is what we have shown, the inner n-2 books. So that is F and F, and here is n-2 mg, and this is the friction. What friction between the books? So FBBM and FBBM. So limiting values, because sliding is about to occur. Now what we write here, summation Fy equal to 0. This 2 FBBM is equal to n-2 mg. So from expression of the limiting friction, we get, what is that? Mu bb into capital F. So here what we get, n-2 is equal to 2 mu bb into capital F upon mg. On substituting given values, what we get? n-2 is equal to, that is 0.25 into 120 upon 0.4 kg into 10, and that is n is equal to 17. Here this will be 15, so here 17 books. So it is obvious this is a condition. What second condition? Sliding will initiate between the inner n minus 2 books and the n books. Actually, if you draw graph between of this equation and earlier, showing a value of this actually number of n and books and f, because f is variable here, and you can see these two graphs have different slope and but straight line, so they will intersect at some point. And if you draw that graph, and you can visualize or you can understand the condition in much more easy way. So what is there here? Sliding between the stack of the inner n minus 2 books and the 2 n books will initiate with the lesser number of books in the stack as compared to sliding between the n books at hands. Thus, total number of books in the stack are 17. So this is the solution. Now let us come on the next question. Example 04, that is question number 37 of Build Up Your Understanding. And what is this question? In the given setup, a bar B is sandwiched between bars A and C that are connected by a light inaccessible thread which passes around an ideal pulley. Masses of each bar is m. Coefficient of friction between the bars is mu, and the floor is frictionless. Acceleration of free fall or gravity is g. If a horizontal force F is applied on the axle of pulley as shown, find acceleration of the bar B. So that is system. Here this force F is applied. Now you have to find acceleration of the bar B. Actually, value of force F is not given, so we have to explore the acceleration of bar B for a range of the force F, because from 0 to some maximum. Now we have to again think the mechanism of solution and the key factors affecting the solution. So very key factor is, let us see, consider first. When sliding at a pair of surfaces in contact is about to initiate, the friction required there to prevent sliding, that is static friction, becomes equal to its limiting value. So when sliding is about to initiate, the static friction will reach its limiting value. One more thing here, since the floor is frictionless, the block C will begin to slide on the floor even for an infinitely small value of the force F. That is very key factor, because here is no friction, but there are friction. So at some higher value of this force F, sliding between the bars will initiate. But sliding between the bar C and the floor will initiate for a very small value of force F. And initially, as the force F is increased, all these blocks will start sliding together with the same acceleration without slipping between them. So, and as the force F is increased, slipping will start either between A and B or B and C. It will depend on condition where the slipping will start first. So that is the idea here. Therefore, as the force F is increased from 0, all the books accelerate with the same acceleration without any sliding between them till force F reaches a value at which sliding between any two pair of the books begins. So what we decide? The value of force F when sliding will first initiate, and we don't know whether the sliding will initiate between A and B or B and C. So first sliding will initiate in one pair of the contact, and then for more higher value of force F, sliding will initiate on the remaining pair of contact. So actually you can see here, your answer will contain three ranges. First, from 0 to that value when sliding between first pair of contact will start, and from this value to the next force F when second place sliding will start, and thereafter all the books will have different acceleration. So we have to decide these two values of the force. So first to decide the value of force F when sliding will initiate between any two pair of the block bars first. And for that we certainly need the limiting friction. So let's calculate the limiting friction between the book A and B, or blocks, or you can say bar between A and B. So we designate it by Fsma is under the block A. So Fsma is equal to mu mg, because here the normal action is equal to weight of the block A. Similarly, between blocks B and C, so that is we denote it by Fsmb. Fsmb is equal to 2 mu mg, because here normal action is 2 mg. And why we call it B? Because we are using notation under the block B. So this friction will act on block B from at its bottom and on block C at top. And then again this friction will act on the block A at bottom and block B at the top. And now how we'll proceed with the solution? There is one way. We should decide the direction of frictional forces and then proceed. But for the first range of value of F, actually when there is no sliding, all the blocks are moving with the same acceleration, we can apply Newton's law on the entire system of the three blocks. So there will be only external forces, that is here F by 2, here and F by 2. They will govern the acceleration. So there is no need of finding the internal force of friction, so their direction. So we do this thing, and actually in this process, you see later, the direction of frictional forces will automatically be decided. Acceleration of the blocks with no sliding between them. So here, applying NLM on the system of the three blocks, we get here, that is F by 2, F by 2. We are showing only the horizontal forces, and we are not shown here the vertical forces because there is no acceleration in that direction. Again, there is no friction at the floor. So here that will be 3ma. Here A is what? Acceleration of block A as well as that of B as well as that of C. So we can write here A of A is equal to A of B is equal to A of C is equal to F upon 3m. So that is what acceleration of all the blocks. Now to decide direction of friction, we can apply Newton's law on bar A and bar C separately. So NLM on the bar A or block A, here F by 2 plus minus Fsa is equal to F by 3. How we can write here? F by 2 is external force. The static friction here may be in forward direction or may be in backward direction. So we taken plus minus. And that will be mass into acceleration. So m into A of A. So m into A of A is what? F by 3. So certainly we can see F by 3 is smaller than F by 2. So here we'll have minus sign. So F by 2 minus Fsa is equal to F by 3. So on the bar A, the friction is acting in backward direction. So on bar B, the friction will act in the forward direction from block A. So direction of this friction has been decided. Similarly, if you write NLM on block C or bar C, the friction between B and C, its direction will be decided. NLM on the block C, F by 2 plus minus Fsb is equal to F by 3. Again, F by 3 is smaller than F by 2. So here we have minus sign. So bar C, friction from B will act in backward direction. So F by 2 minus Fsb is equal to F by 3. So on bar A or block A and block C, frictions are in backward direction. So both the friction will act on the bar B in forward direction. So here direction has been automatically decided. And again, we know here the range for F we have to calculate, but direction of the frictional forces on the block A as well as on the block C are backwards. Thus both these frictional forces on B must be in forward direction. So that is very important decision we have taken. From the previous two equations, these two equations, here we get what? Fsa is equal to Fsb is equal to F by 6. How? Actually, what these two equations suggest that these two forces must be equal because they are identical equation. And from any of the equation we can find the friction force. Fsa is equal to Fsb, and that will be F by 2 minus F by 3, that will be F by 6. So value of frictional force is what? F by 6. Thus when there is no sliding between the blocks, both the static friction will be equal and increase with F. The limiting friction between blocks A and B has smaller value. So sliding between A and B will begin first. Now let us see, that is not always the case, but here actually both the static friction will start increasing together with F, and they're always equal. So the friction which has lower limiting value will reach its limiting value first. So sliding will initiate there first. So FSA has lower value. So sliding between A and B will start first. And FSA will, what we have seen earlier, that is mu mg. So at that time, what will value of force F equal to 6 mu mg. So FSA is equal to F by 6 is less than or equal to mu mg. So F is less than or equal to 6 mu mg. So till this range, all the blocks will move together or their acceleration will be same. So what we can write here, thus for no sliding between the blocks, A of A is equal to A of B is equal to FC is equal to F by 3m, that is, and for all F is greater than or equal to 0 and less than or equal to 6 mu mg. So that is first result we have obtained. Now it is decided that sliding will initiate between A and B first, and second sliding will start between B and C. So we decide when sliding between B and C will start. The force F at which sliding between the block B and C will initiate or begin. What we do for that, friction between the blocks A and B is kinetic, and between B and C it is still static and has its limiting value when sliding starts. Directions of these frictional forces are shown here, as we have taken earlier, that on A and C it will be backward, and on B both the friction will be in forward direction. So that is and this way. So direction we have seen. Now what we do, NLM on the system of blocks B and C, because B and C are still moving together, they have same acceleration. So that is here this friction in forward direction, what, mu mg, and this is force F by 2, that is from sting on the C. So this friction, what, FKA is equal to mu mg. Only these two horizontal external forces are acting on this system. So that will be what, mass 2m into A. So from here we can find F by 2 plus mu mg is equal to ma. So now we can write NLM on the block B. So for block B, what it will be, just because we have to find whether the sliding will initiate between B and C or not, or when the sliding between B and C will initiate. So when sliding initiate between B and C, at that time their accelerations will become different, or before sliding initiates their accelerations are equal. So let us apply Newton's law on block B. So block B, this frictional force is acting in forward direction, and this frictional force 2 mu mg is also acting in forward direction. So FKA is equal to mu mg, and Fsmb is equal to 2 mu mg, because sliding is initiating at this contact, so this friction will reach its limiting value. So what is the maximum acceleration possible? So that is ma for block B. So A is equal to this mu mg plus 2 mu mg, 3 mu mg is equal to ma. So A is equal to what? 3 mu g. And now if you solve these two equations, you will find the required value of F when sliding between B and C will initiate. So by simultaneous solution of these two equations, we will eliminate the acceleration. F is equal to 10 mu mg. So when the force F will become 10 mu mg, sliding between B and C will initiate. So for the range of F greater than or equal to 6 mu mg and less than or equal to 10 mu mg, A has different acceleration and B and C have the same acceleration. So let us write that acceleration. Thus, for no sliding between the blocks B and C, but sliding between A and B. Actually in the problem, acceleration of all the blocks is not asked, only acceleration of block B is asked, so we'll write acceleration of block B only. So equation is what, the range is 6 mu mg, F is greater than that and less than or equal to 10 mu mg. So now from NLMs of system of blocks B and C, what we get, the same equation. So A of B is equal to A of C is equal to F plus 2 mu mg upon 4m. Actually, that was the idea here, this acceleration. So this will give the acceleration of block B. For all F is greater than or equal to 6 μmg or less than or equal to 10 μmg, that is equation number 2. Now you can, I'm leaving the solution of these equations on you, so you'll get this result. Now what will happen when the force is increased beyond 10 μmg? Sliding between all pair of contact will start. So we can treat the block B separately, and here this will be the free body, the FBD of the block B, and its acceleration will become constant because this friction will also μmg and this friction will also become 2 μmg. If F is greater than or equal to 10 μmg, there is sliding between the block B and C also. So NLM for the block B, for this range of force, here is the force Fk μmg, and here Fkb is equal to 2 μmg, that is equal to Ma of B. So what is A is equal to 3 μmg upon M, so that is 3 μg. So that is third range of acceleration. Now from equation 1, 2 and the above, what we get? Acceleration A, B equal to, for first range, what it was? F by 3m, and range was F is greater than or equal to 0 and less than or equal to 6 μmg. Now second range, F is greater than or equal to 6 μmg and less than or equal to 10 μmg. So we have obtained earlier, we are writing the equation F plus 2 μmg upon 4m. So that is range. And when F increases beyond 10 μmg, so AB will be 3 μg. So that is the answer of the situation. Actually, this problem was somewhat similar than the 3-block problem, but here forces are applied on 2 blocks A and B, and the forces were always equal. So again we have seen, that is, if you have thought all the qualitative decision earlier, then writing of equation will become simpler. Actually, thinking qualitative solution earlier will guide us which equation way to write. Now let us see the question number, next question or next example. Example 5, that is question 39 of build up your understanding. A bar AB and a block P are placed on a frictionless horizontal floor with their adjacent vertical faces in contact, as shown in the figure by a top view. Here, XY plane of a coordinate frame is in the plane of the floor. The bar is made to move horizontally along the floor in a straight line with a constant acceleration without rotation. Direction of motion of the bar makes an angle theta equal to sine inverse 0.6 with the positive x-axis. Coefficient of friction between the block and the bar is mu is equal to 0.75. Find distance traveled by the block until the bar moves a distance L is equal to 40 centimeter. So that was situation is given. Now please take care of this thing, that is top view. Top view means mg will be what? Downward means into the page. Mg will not be in this way, because in some situation when top view is given, I have seen that students are committing this mistake. We have usual habit to show mg in this direction, but mg is downward. So what here, the top view, so mg will be just into the plane of figure, and n will be n from the floor will be out of the figure. But these two forces will always counterbalance, and there is no friction from the floor. So there is no need to show this force and consider them at all. Now this is what a vertical face, and there is contact between bar and vertical face, and friction coefficient here is what given, mu is equal to 0.75, and the bar is made to move in this direction with a constant acceleration without rotation. So bar will move just like that, and it will push the block as well as drag the block in this direction. So here there are two situations, whether the block will slip on the bar or not. If the block does not slip, then distance moved by the block will be equal to that of the bar. But if it slips, the distance will be somewhat smaller. So here the key decision is what? We will decide whether the bar will slide, the block will slide on the bar or not. So how we proceed? Let's again, what the idea we have just discussed, let us document them. Weight of the block is counterbalanced by the normal reaction from the floor, as these forces do not contribute the motion of the block as well as to any friction. They are left out of consideration. So that is very important idea. It will make things simpler. Now we have to show only the forces in this XY plane. The sense of sliding or its tendency between the bar and the block is apparent. Thus direction of the frictional force between the two. This friction on the block is in the positive X direction. The normal reaction necessary for this friction is provided by push of the bar in the positive Y direction. Actually, as the bar will move in this direction, so it will try to drag the block in the positive direction. So dragging on the block is in positive direction. This dragging is provided by the frictional force. So friction on the block will be in positive direction, and necessary normal reaction for this friction will be created by push by the bar on the block in positive Y direction. So that was the idea here. Whether there is slipping between the block and the bar or not can easily be decided by comparing the friction required to prevent sliding with the limiting friction. So if we calculate friction required to prevent sliding, if the friction required to prevent sliding is more than the limiting friction, there will be slipping. If the friction required to prevent sliding will be less than the limiting friction, there will not be slipping. So in that way, we try to decide whether there will be slipping between the two bodies or not. Required friction Fre for no sliding between the block and the bar. If there is no sliding between the block and the bar, acceleration of the block must be equal to that of the bar. Let the acceleration be denoted by A. Actually, this acceleration is not given, so let us denote it by A. So here this N, this normal direction is provided by the Y direction of the push by the bar, and this is friction. We have seen it must be in positive direction. So this bar has acceleration A, and this acceleration must be in theta direction because there is no sliding. So acceleration of bar and block will be same. So we don't know the magnitude, but we know the direction. So let us see the direction here. So again, we resolve the force into two components, X and Y. X is given X and Y. So here, what you can write, these two lines show the length of component. So this will be MA cos theta, this will be MA sin theta. So summation Fy equal to MAy, it will provide the normal reaction. So N is equal to MA sin theta. Summation Fx is equal to Mx. So it will what? Fre is equal to MA cos theta. Now we can write, it is given that theta is equal to sine inverse 0.6. Actually, theta is given. So from here you can find sine theta is 3/5 and cos theta is 4/5. Actually very known value. Here theta is 37 degree. Now from that we can substitute the values here. So what we have here, from the above equations we get Fre is equal to 4/5 MA, because cos theta is 4/5. So Fre is 4/5 MA. The limiting friction Fsm will be what? Mu into n, and we know this, and mu is what? 0.75, so 3/4. So Fsm will be mu into n. So that is mu Ma sin theta, and is what? Ma sin theta. We substitute value of mu 3/4 and sin theta 3/5. So substituting mu is equal to 3/4 and sin theta is 3/5, we get Fsm is equal to what? 9/20 MA. And certainly we can see F required is more than Fsm. So there will be slipping. comparison of Fre and Fsm, the expression obtained suggests that Fre is greater than Fsm. Therefore, the block slides on the bar and frictional force between them is kinetic. Thus, what we can write here, Fk is equal to Fsm, that is 9 by 20 MA. So this will be what? Frictional force, the kinetic friction we have known and direction we have seen. So there is sliding between the block and the bar. So distance moved by the block will be smaller than that of the bar. Now we calculate the distance, and that is simply kinematical decisions. So what is constant relation? Constant is component of acceleration of AB, means block in the y direction must be equal to that of the bar. Thus what we can write here, ABY is equal to A sine theta. So if we denote acceleration of the block in some direction, so it's vertical, this is not vertical, its y component will be equal to y component acceleration of the bar. So ABY is equal to A sine theta. Only we have to calculate x component acceleration. For this we applied Newton's law on the block. Now by applying NLM on the block, we can find its x component of acceleration in terms of acceleration of the bar. So that is the n, and here Fk, that is what? This MAB. So this will be here, we can show the component MAX, and this MAY, that is this is what? A sine theta. So it will be MA sine theta. So ABY is what? A sine theta. So this. Now this will provide us value of n. So summation Fy is equal to MAY will give n is equal to MA sine theta. And from here we can find Fk is what? Mu n. So MAX. So Fk is equal to mu n. So what is Fk? That is mu MA sine theta. Now F from x component, Fk is equal to Mx, so we can find Ax. Summation Fx is equal to Mx, but it provides Fk is equal to Ma Mbx. Basically, this is Mbx, so we written here Mx, Max. So from the previous two equations, from these two, what you can write? Abx is equal to this force upon m mu A sine theta. So x component acceleration of block is given. Acceleration of the blocks is a constant because its y component as well as x component both are constant. And what is magnitude? Just square this and square this and 8. So what is acceleration of block? Abx square plus Aby square. So if you square this and square this, you can say and you take a square root. So A sine theta will be common. So in square root, what you will have? 1 plus mu square. Now by substituting values of Abx and Aby, we get AB is equal to A sine theta square root 1 plus mu square. So acceleration of block we have found. We know that its magnitude is constant as well as its direction is constant. Similarly, magnitude of acceleration of the bar is constant as well as its direction is constant. So we have in a position to use the kinematical equation of displacement with constant acceleration or uniform acceleration. Starting from rest, the block moves without change in direction with a constant acceleration. AB is equal to A sine theta 1 plus mu square root. Thus distance traveled in time t will be equal to its displacement, and initial velocity is 0. So what is that is half A of b into t square. So we can write here, we denote this distance by SB, half A of b into t square, and substitute the value of A of b. So SB is equal to half A into sine theta into 1 plus mu square root. Let us call equation number 1. Similarly, we can calculate distance of the bar, and it is given L. So L will be equal to what? Half A into t square. Starting from rest, time taken by bar to cover a distance L with a uniform acceleration A. So we can use a similar equation. So here L is equal to half A into t square. So t is equal to 2L by A square root. Now we substitute this value of t from equation 2 in equation 1. from equation 1 and 2, the distance covered by the block, that will be very simple, as b is equal to L sine theta square root 1 plus mu square. So that is the final answer. Now we have to substitute only the given value. So what the values are? L is 40 centimeter, sine theta is 3 by 5 and mu is equal to 3 by 4. So by substituting these values, you can simply find SB. By substituting the given values, we get SB is equal to 30 centimeter. So that was the idea. But here we can have some more interactive solution. And there is an alternative way of solution. Let us discuss it also. Alternate method. Whether the block will slide on the bar or not, that is the decision. So this decision we can take in a very simple way. We make use of geometrical method, because you can see here on the block, actually there are in horizontal plane, what force is acting? Only the contact force, total contact force, and that must be in the direction of the acceleration of the block. If there is no sliding, angle between the total contact force R and the normal reaction cannot exceed the angle of friction phi, basically angle of static friction. So that is critical reason. Now how we can see here, for no sliding, acceleration of the block is equal to that of the bar, so it will be in theta direction. So we can try to write here Newton's law and we draw the FBD. So R will be in this direction. So MA must be in the same direction. So angle of R with the normal direction must be equal to what? 90 minus theta. So here we can show these components, and component of R, that will be N, that is FRE. So this angle is angle of friction. So here MA cos theta, and this is what? MA sin theta. Now what is that? For no sliding, phi must be equal to or smaller than 90 minus theta. So what you can write here, first equation. So summation Fy is equal to MAy. So N is equal to MA sin theta. And summation Fx is equal to Mx. So Fre is equal to MA cos theta. Now what is the required condition for no sliding? This angle phi must be equal to or smaller than angle this 90 minus theta. So with the help of the above results, we get tan phi is greater than equal to Fre by N. So this is what required condition. So tan phi is greater than equal to cot theta, because we have seen earlier phi must be greater than or equal to what? 90 minus theta. So how we can write here this condition, basically for what that is will slide. On substituting the given values, what we get? Tan phi is greater than equal to cot theta, and this is what? 3 by 4, and cot theta is sine 6. So this is 37, and cot 37 is 4 by 3. So 3 by 4 is greater than 4 by 3, that is invalid condition. And how we have decided this equation? Because phi must be greater than this angle. So if the phi is greater than this angle, there will be no sliding. But if you assume no sliding, the condition what we are getting, that is invalid. So there must be sliding. The above condition is invalid. Thus, the block will slide on the bar. So sliding we decide in that way also. Now, the only thing is what? We have to find the distance traveled by the block. So here again we take some geometrical method. As the block slides on the bar, friction is kinetic, and thus net force on the block by the bar is a constant and equal to the total contact force. So acceleration of the block will be in the direction of the total contact force R, that is only force. See here, as the block starts from rest and moves under the action of the net force, that is the total contact force R, the block will move in the direction of the total contact force as shown in the figure. Now how we can see here, that was situation. As the bar moves, so you can see this will be the way of motion. You can see the block is sliding. You see, we can again see here, see how it will move. That way. So block has moved from this place to that place. So that is what first line where the bar was and second line where the bar was. So this will give the y displacement of the bar. Now say at this midpoint the block was placed earlier. So that is what distance slid by the bar. So this angle will be theta. Now we can show here SB. The block has moved from here to here. So this angle will be what? That is we denote it by phi. And this is what? This must be in the direction of total contact force we have seen earlier. So this angle phi is 37 because it is sliding. So angle of total contact force and normal direction. The angle between them will be the angle of kinetic friction, and the friction coefficient is what? 0.75. So tan inverse 0.75 is 37. So this angle of kinetic friction is 37. So this angle will be what? Again phi. So if this angle is theta, so this angle will be theta. And if this angle is what? Phi, this angle is theta, so we can write, and this angle is again theta, so we can write here this angle 90 plus phi. That is not very difficult to find. How? This angle will be what? 90 minus theta minus phi. And to find this angle, we have to subtract from 180 this angle and this angle, we get this. So this angle will be what? 90 plus phi. Now we are in a position to use sine rule in this triangle OAB. So applying sine rule in triangle OAB, we get what? That is SB upon sine theta. That is this length upon sine of opposite angle equal to this length upon sine of this angle equal to L upon sine 90 plus phi. And sine 90 plus phi is cos phi. So what we have? SB upon sine theta equal to L upon cos phi. So what we have? SB is equal to L sine theta upon cos phi, or L sine theta into sec phi. So SB is equal to L sine theta into sec phi, and sec phi is 1 plus tan square phi square root. So SB is equal to L sine theta 1 plus tan square phi, and tan phi is mu, so it is what? 1 plus mu square. So we got SB is equal to L sine theta 1 plus mu square. So in this way, we have again seen, if you are able to use this geometrical solution, the solution is quicker than using component method. And now the task is remaining only to substitute value and find the answer. So by substituting the given values, SB will be 30 centimeter. Now let us discuss the next example. Example 6, that is question 41 of Build Up Your Understanding. The question is a wedge of mass capital M is equal to 3 kg rests on a horizontal floor. Slant face of the wedge max angle theta is equal to sine inverse 0.6 with the horizontal. A block of mass small m is equal to 5 kg is released on the slant face. Coefficient of friction between the floor and the wedge is mu is equal to 1 by 3, and the slant face is frictionless. Find the force of the normal direction between the block and the slant face. Acceleration of free fall is z is equal to 10 meter per second square. Now, what is the critical decision in this problem? Critical decision is the proper question of this problem is whether the wedge will slide or not. If the wedge is not sliding, the normal direction between the block and the wedge slant face will be simply small mg cos theta. But if the wedge is sliding, this normal direction will have somewhat smaller value, and that we have to calculate. So here the force of normal reaction between the block and the slant face depends on whether the wedge slides on the floor or not. Thus, we have to decide this first. And what you do for this decision? the wedge slides on the floor or not. For this purpose, we have to find the friction required to prevent this sliding and compare it with the limiting value. So normal reaction between the block and the slant face of stationary wedge is mg cos theta. So it is a very obvious reason. If the wedge is not sliding, the normal reaction will be mg cos theta. Here normal reaction is known. So what the case we are doing, we are finding required friction to prevent sliding. So we are assuming there is no sliding. So now we are in a position to apply Newton's law on a stationary wedge. So all the forces we can show here, this n, here mg of the wedge, and now this normal action mg cos theta, because we have assumed the wedge to be stationary. And from here will be normal action from the ground, because this will provide the necessary friction. So the horizontal component of this normal reaction will push the wedge towards right. So friction will be in this direction. So what we call Fre. So we take x and y component in this direction. So this is equilibrium condition. So first here component here, this component and this component. So this component we can see mg cos theta and cos theta. So it will be mg cos square theta, and this will be what mg cos theta into sin theta. So summation fx is equal to 0. What it gives? Fre is equal to mg cos theta sin theta. So that is required friction to prevent sliding. Now what we find from Fy equal to 0 and from ground is equal to capital Mg plus small mg cos square theta. That is, the limiting value will be at mu into Ng. So Fsm is equal to mu into Ng. So what we have? Fsm is equal to mu mg cos square theta plus capital M, and G we can take common. Now we have to compare this value Fsm and Fre, and we'll see if Fr is less than Fsm, so there will be no sliding between the wedge and the floor, and the normal action between this block and the slant face will be this mg cos theta. But if there is sliding, so at that time, to decide this normal action, the situation will be somewhat more involved. So let us see by comparing these two forces. Condition for sliding of the wedge on the floor. Fsm must be greater than or equal to Fre. If this is what, there is no sliding. But if it is not, there is sliding. What we have assumed, there is no sliding, so static friction must be, limiting value must be greater than required friction, or required friction to prevent sliding must be well within the range of the static friction. So this we have calculated mu m cos square theta plus capital M into G, and this we have calculated mg cos theta sin theta. So G and G will cancel out. So from here mu must be greater than or equal to m cos theta sin theta upon m cos square theta plus capital M. Now we substitute the values. Substituting the given values, what we get? This is 1 by 3, and that is what 5 cos of sine inverse 0.6, and this is what sine of sine inverse 0.6 upon, that is 5 cos square of sine inverse 0.6 plus that is mass 3. And if you solve this, what you get here? Here this is 1 by 3, and here we will get 12 by 31. And certainly 12 by 31, what we can see, the above condition is invalid. Thus, the wedge slides on the floor. And how this condition is invalid, you can compare this 1 by 3 and 12 by 31. Certainly 12 by 31 is not smaller than 1 by 3. It is greater than 1 by 3. So this condition is invalid. So we have got the wedge will slide. So if the wedge will slide, the normal action between the block and the wedge is not mg cos theta, and now we have to calculate it. And if the wedge slides, it will have some acceleration, and this acceleration will affect the acceleration of the block. So how these kinematical constraints are affecting this each other, let us think. Constant relation denoting acceleration of the wedge by letter A and that of the block relative to the wedge, means sliding, by B. We can show that, and we have done it very earlier. So this acceleration we show this B, That is B means along the slant face. So this is what sliding acceleration. So it is what related to wedge, and acceleration of wedge is A. So this wedge will carry this block with it. So this acceleration A will be added here also. So acceleration of block with respect to ground will be resultant of this A and B vector. So it will be somewhat in this direction. But there is no need to find the resultant. We'll take care of these two components only. The block slides on the slant face of the wedge with an acceleration B vector with respect to the wedge, and the wedge moves with an acceleration A vector towards the right as shown in the figure. So that is what constant or kinematical relations we have seen. So now we are in a position to find Newton's laws, and on the block as well as on the bar, because here in this situation you can see the number of unknowns. Number of unknowns are A and B. Two unknowns are there. One normal direction from the ground, and second normal direction between these. So there are four unknowns. So we have to write four equations. Now how we can write this equation? Let us see here. An LM for the block. So this force mg is acting from the normal at angle theta. So that is normal. So only two forces will act on the block because there is no friction between the slant face and the block. And its kinetic diagram MB and here MA. This is MB and MA. Now orientation of the coordinate system will be obvious here. Along the normal we take y direction, along the slant face as x, this way. If you take this way, the equation will be somewhat simpler. So what we can write here, this components, this line will show the component of mg, and these two lines dash dash will show the component of ma. So here this mg sine theta, obviously this is what mg cos theta. So this is what mg cos theta, this will, sorry, ma cos theta, it will be ma sine theta. So summation fx is equal to max. So what we can write here, mg sine theta is equal to mb minus ma cos theta. So mg sine theta is equal to mb minus ma cos theta, equation number 1. Similarly, summation fy equal to may. So what we have, ay will be in this direction. So mg cos theta minus n is equal to ma sine theta. Equation number 2. So we have four unknown a, b, n or ng. So we are still required to write two equations, and these two equations will be written with the help of applying Newton's law on the wedge. So NLM for the wedge. So here the free body diagram. So that is mg, and here the normal direction. Please take care, its value now will not be mg cos theta. So we'll take n. Here is the normal direction from the ground. So horizontal component of this n is towards right. So it will create a sliding tendency in the wedge, or it will make the wedge to slide towards right, and we have seen that wedge is sliding. So it will have kinetic friction. Fk is equal to mu ng, and that will be equal to capital M into A. So here we have two equations, one for x component and one for y component. So let us write those equations, and for this we have to take components of n only. So it will be what, n cos theta, this will be n sin theta. So summation fy equal to 0, may, and may is 0. So what we have, ng is equal to this force plus this force. So n from ground is equal to capital Mg plus n cos theta, equation number 3. And summation fx is equal to max. What it be? This force minus this force is equal to this effective force. So what we have, n sin theta minus mu into ng is equal to ma. So equation 4. Now from these four equations we can find n, and that calculation I'm leaving to you, and you can verify it, and I'm giving you the answer. From the above equations we get n is equal to small m capital Mg cos theta plus mu sin theta upon capital M plus m sin theta into sin theta minus mu cos theta. And by substituting values you can find 37.5 Newton. So that was a few examples what I have taken from Pathfinder, from friction. And what I suggest you, just if you are not in a position to complete the book, just solve these problems what I am taking here. And whenever you get time, try to solve other problems. Again, what I have recommended in the preface, that if you are preparing only for JEE Advanced and you have intention to acquire a good rank, especially in top 100 and top 50 or top 10, concentrate to solve the build-up of understanding and MCQ. But before you start MCQ, try to solve the build-up of understanding, and if you have time, solve the entire build-up of understanding. And if you have not enough time, then try to practice only those problems what I am taking here example. So few problems I have taken of Newton's law without involving friction, and few problems today I have taken involving friction. And in next lecture, when I consider Pathfinder examples, I take some problems involving Newton's law on circular motion. And in this way, that is built up will be covered, and thereafter I will ask you to attempt the MCQ. But anyhow, try to attempt the MCQ completely. Now it is turn to decide today's homework. Home assignment: revise all the ideas covered today in this lecture. Attempt exercise 01 of module till question 70. Actually, few questions I have given it to you earlier, but from exercise 1 to 70, try to complete this list of questions. Thanks for patient listening today. We'll meet in the next lecture, and in the next lecture we discuss the application of Newton's law to analyze dynamics of circular motion or curvilinear motion. If I had an hour to solve a problem and my life depended on the solution, I would spend first 55 minutes determining the proper question to ask. For once I know the proper question, I could solve the problems in less than 5 minutes. Albert Einstein.